Hello. Here in a valley which is close to the Tachiki station. Our station is halfway between Kyoto and the Japanese sea coast. Today is April 10 and here in this valley Mitsumata still flowers. This is a wonderful, adorate, attractive and extremely useful Chinese plant which was brought to Japan long ago, and the main reason was to use bark for the production of the very high quality paper. That paper is still used to make Japanese banknotes. So Mitsumata might be called the money tree, or better to say money shrub. Life form of Mitsumata is very remarkable. First of all, you will see this smooth bark on branches, and then in the springtime, wonderful white and golden. First golden, then whitish flowers. The family is Daphne family, Thymilaceae, and please be aware that most of Thymilaceae are poisonous. However useful they are. Mitsumata, in addition to all this wonderful appearance, all this remarkable habit, all this useful application as ornamental and fibrous plant, so fibrous, then branches are like a rubber, so it's easy to hold on them if you want to climb up or down the slope. In addition to all of that, Mitsumata has amazing feature, well, one of the most unique system of branching in the whole plant world. So normally, well, if you want to make two cells, you will simply split it in the middle and will distribute DNA half to half between daughter cells. That's clear. And DNA is a double spiral, so double spiral is easy to distribute between exactly two cells. So when cells united in multicellular bodies, some cells are responsible for branching. In that case, the branching cell will produce two, and each of them will make its own branch. We call it dichotomous branching, probably the most ancestral branching among plants. But then, at some point, and we still don't know exactly how it happened, cells, terminal cells, became multiple. So in all seed plants, starting from cycads, ginkgo, and conifers, and of course in flowering plants, there are multiple meristematic cells, which will, well, kind of concertedly divide and produce lateral branches. So from that point, dichotomous branching, like branching it two, in a perfect way is not possible, well, by principle. So all branching afterwards is kind of monocotomous, but a result might be different. There are plants which branching at least seem to be dichotomous. In that case, the terminal bud or terminal meristem disappearing, and two equal lateral branches appear to make an, well, kind of visible dichotomous, which we typically call pseudo-dichotomous branching. Not very infrequent. If you look, for example, on any lilac, you will see that terminal inflorescence next year will die, and two vegetative branches will give you appearance of dichotomous, which in truth is pseudo-dichotomous branching, because the terminal bud existed for some time. And now to Mitsumata. Look on branches. Mitsumata is the only flowering plant which has visible triple branching. So each branch, almost without exception, well, exceptions possible. Everywhere in the living world there are exceptions. I can find it for you. For example, that branch has two, but there is a third one which is degrading. Anyway, so, but most of them have three branching. So Japanese name will reflect that, And Mitsumata was not only observed as trichotomously branching, but also researched in a deeper way. And what was found? That triple branching start to be very close to the development of branches, not like a inflorescence like in a lilac develop and then die. Next year we see some. Nope. It's seen exactly from the beginning. Terminal meristem will behave in a way that three equal branches will continue the growth. This is absolutely unique and, well, the only example, as far as I know, of the pure, we can call it pseudo-trichotomous, of course, because it was still the terminal meristem, but trichotomous, triple branching. So, famous Mitsumata on April 10, plant with absolutely wonderful flowers, extremely useful bark, beautiful appearance, and a botanically unique triple branching. Thank you so much.